Welcome to an educational tutorial on analysis of variance, ANOVA, for agriculture yields comparison. Introduced by Prof Ronald Fisher in 1923, ANOVA examines the mean differences in more than two independent dataset random samples. When used for comparing two groups' mean differences, it transforms into a two-mean standard t-test. If applied to one independent variable with reference to two or more dataset groups for mean difference testing, it is known as one-way ANOVA. Moving on to more complex scenarios, when ANOVA is applied to more than one independent variable with respect to two or more dataset samples, it is termed as two-way ANOVA. ANOVA is a parametric test for normal distribution that classifies dataset variance into separate constituents: variance within separate groups, error variance, and between-group variance. The variance between the groups is the indicator of chosen subject, resultant outcomes, indifference variability, while the variance within the groups being group subject's intrinsic variability. The variance between group samples indicates larger variance when groups are relatively separate with respect to the examined variable. Conversely, the variance within group samples is smaller as groups are more homogeneous. By analyzing the mean value differences, ANOVA helps in identifying real group differences based on the variance ratios. To calculate ANOVA, correction factors are determined for group samples, followed by the calculation of total sum of squares, TSS, and sum of squares between groups, BSS. The sum of squares within groups, WSS, is then derived by subtracting BSS from TSS. Variance between groups and within groups is evaluated by deducing the degrees of freedom and F ratio. By comparing the F ratio to the significant value, ANOVA helps in determining whether to accept or reject the null hypothesis regarding the significance of group sample differences.